Hello, good afternoon. We are waiting for 2-3 minutes. Hello and good afternoon. Today's we are fifth week of problem solving session. My name is before start today's session. I am introducing myself. My name is Prabir Maiti. I am teaching assistant of this course. The course name is Symmetry, Stereochemistry and Application. And course instructor was Professor Ongsuman Roy Choudhury. Today's classes we are mainly focusing some problem related to the symmetric, disymmetric and asymmetric molecule. When a molecule which have the improper axis of symmetry like Sn, see that molecule have that improper axis of symmetry, then this will be symmetric molecule. And if there will be no improper axis, so that molecule may be disymmetric. But if that molecule have some rotation, like symmetry operation, if that molecule have that symmetry operation but not that as an improper axis, then molecule will be disymmetric molecule. But if that molecule have no improper axis and also not have any symmetry rotation, then that molecule will be asymmetric molecule, and asymmetric molecule also known as that chiral molecule. So now we saw some example like that. So this molecule, that ethanol, which have the two hydrogen, if one hydrogen we have replaced by the deuterium, so then what will happen? So then this molecule as chiral molecule which have the non-superimposable mirror image to each other. So if these are chiral molecule which have the non-superimposable mirror image, so then this molecule are asymmetric molecule. Like any amino acid, like general amino acid from, so only one amino acid that on the glycine, where the R is replaced by the hydrogen, so which are not chiral molecule. But apart from glycine, there will be another amino acid where that R will be methyl, which will be alanine molecule, which have the chiral center. So any amino acid rather than glycine one, all are have that chiral center and all have that asymmetric molecule which rotate the plane polarized light, optical polarized light, and which have behave as a chiral molecule. And these are all are asymmetric molecule. Now we are going to solve some problem. So first one, that we have to indicate that molecule is symmetric, disymmetric or asymmetric. So if you saw the first example, so now we can draw this molecule like this way. So the molecule will be like this, where it is showing that 2 methyl is half. So now I am drawing like this, that the 2 methyl is half, and this is hydrogen. Here also 1 methyl is half. Similar, here 2 methyl is down. If we want, this one will hydrogen. So downside is methyl, I am not writing. So this molecule is symmetric, disymmetric or antisymmetric. We have to answer it. So how we can solve this problem? So I have told like that if the molecule have the symmetry, then that molecule will be uh, symmetric molecule. So to check that this molecule have SN symmetry or not, we rotate this molecule like 180 degree. So from here, like a like a rope, we can connect to the molecule into that in the middle, and we rotate this molecule like 180 degree. So if we rotate this molecule 180 degree, what will happen? So these two methyl which are is up, this will go here, replaced by this one, and these two methyl which are down, so these are coming here. So I am only hydrogen I am giving, and methyl which are not I am giving. So if you rotate this one, so how the molecule will be now look like this. So these two methyl which are here is coming now here, and the two methyl which are down, here also in down. Here the two hydrogen. Now if we that place a mirror, essential property of symmetry is like that. If you rotate, like their molecule have there some C, then after that you get the mirror image. Then if you saw that this two the after mirror image the molecule is like that original molecule, then that molecule will be have that SN, that is the improper axis of symmetry. So that mirror image will be like this, that 2 methyl is down, sorry, so this 2 methyl is down and that above 2 methyl is up, like this, which are exactly that the same molecule, where 2 methyl is down here and 2 methyl is up, so which are exactly the same molecule as that first one. So this one and this one exactly the same. So if they are exactly the same, so this molecule have the SN property of symmetry, and this SN is S2, like this are 180-degree rotation. So this molecule have that symmetry molecule. So the answer will be symmetric. Now next cases we have to identify this one is symmetric, asymmetric or not. So this molecule, if we draw this molecule like this, there will be two hydrogen will be like this. So that dotted hydrogen I am drawing like this. So this one like this. So now we have to find out. So this molecule is symmetric, disymmetric, or asymmetric. So now we have to um, rotate this molecule like 180-degree. If you rotate, so if you rotate this molecule, so this hydrogen will be like this, and this hydrogen will be like that. And this 2 methyl. So now we have placed the mirror. Then what will happen? So this hydrogen which are coming here, so this will be like that, and one hydrogen which is the above the plane. These are exactly the same molecule as the first one. So this also have that SN, that symmetry operation. So this also the symmetric molecule. Now the next one. So you have to identify this molecule is symmetric or not. So uh, like earlier I have told, if a center which have the four different substituent, so that molecule have that chiral center, and if your molecule is chiral, so then that molecule never be symmetric, disymmetric or anything. That molecule must be asymmetric. So if you rotate or anything, any operation, only this molecule have that E1, like that this molecule after 360-degree rotation give that molecule, original molecule. But any other such operation not present in that molecule, that give this molecule that same. So this is a chiral molecule, and chiral molecule always will be asymmetric molecule. Now for the next example, we have to find out that this molecule is symmetric, disymmetric or asymmetric one. So if you draw like this molecule, like this way, the 2-methyl is up, the 2-methyl is up, and all are hydrogen. So like this molecule, if you rotate this molecule 180 degree, so this molecule have the sigma plane. So this molecule never be chiral. So this asymmetric never be, this molecule have the asymmetric. Now if you rotate this molecule 180 degree, what will happen? What will get? Like similar molecule of this. And after mirror, also give that same molecule where the 2-methyl is up. So nothing will changed after any operation. So this molecule is a perfectly symmetric molecule where also that S2 is present, also C2 present, sigma present. So this are example of symmetric molecule, not disymmetric or asymmetric. Now next example 1, we have to identify this molecule is symmetric, disymmetric or asymmetric. So if you draw this molecule this way, so earlier I have told that when you start from that left side and your above group is up, so this will be like this. So this is the molecule if you draw. So now there will be no sigma plane here. You can rotate this molecule like from this direction 180 degree, then what will happen? So rotate like this direction. So now that the 2-methyl is already there, now this NH2 will be coming here, and here below NH2 will be coming here. Now if you take that mirror image of this molecule, then what do you get? So this will be your NH2, rest is hydrogen. So how we rotate? We rotate this molecule like 180 degree, this direction. So then we got this after C2, Then after mirror image, we got this molecule at the NH2 here. This will be your hydrogen. Here this will be your hydrogen, and this will be your NH2, which are exactly that same, like this one, and this one two, and this one three. So 1 and 3 exactly the same. So this molecule have that S2. So this molecule not be as disymmetric or asymmetric. So this molecule is symmetric. But if you replaced one of group, like if you replace this one as a COOH, then what will happen? So if you replace one of COOH like this one, so now this molecule don't have that sigma plane. Also, if you rotate this molecule, so now COOH is up. Now COOH here. So now that molecule have not that symmetric, like S S2 operation, like improper axis. So now this molecule is a chiral. So when you replace this methyl as COOH, that molecule be a chiral. But when these are methyl and these are methyl, then that molecule is symmetric. So after replacing that methyl in COOH, that molecule become asymmetric. But when there will be methyl, so this molecule is symmetric. Now for the next one, this molecule is symmetric, disymmetric or asymmetric. So if you draw this molecule, so this molecule have also that sigma plane. So this molecule not be overall as chiral molecule in that center. Now if we rotate this molecule 180 degree, then what we get? Like this direction we are rotating. So all the hydrogen is replaced here. Now mirror image. So if you saw the mirror image of this molecule, now it will be exactly the same to that first one. So this molecule also not asymmetric molecule or disymmetric. So this also has a symmetric molecule hydrogen, and here the NH2. So 1 and 3 are equal. So this not disymmetric or asymmetric. So this an example of symmetric molecule. Now for one example, if you want to draw that all the possible isomer of this molecule, so all of that hydrogen. So in three centers, so how many possible isomer we can draw? So first one we change that first position. So this one is OH, all are we are taking as same. Change 2. Now another one we can draw where second one we change. So first one remaining same. So here will be one hydrogen. Like this. For the next one, so last one we can change. like this way. Another one we can do like this. So first one, keeping like this way. Next one change. That can we draw. For next one, we can draw like this. This one. Or we can draw like another one with the two OHs down. Left hand side. Like this way. Or other possible, we can draw or not. So if you now to show that optically which one is optically active. So optically active means so there not be any sigma plane passed to each other. So this from there will be sigma plane here, sigma plane. So this one may be optically active. This one optically inactive. Meso compound. So where that sigma plane are not pass, like this also sigma plane passed, this also a meso compound, this one not meso compound, this one also not meso compound, this is meso compound, so optically inactive, this one optically active, this one optically inactive. So like that we have to draw all the possible conformation, then we have to tell which one is optically active or which one is not optically active, inactive. Now for the next, so now we have to tell the relation between this HA and HB. They are enantiomer or diastereomer or they are homotropic molecule. So if you replace, so to solve like this problem, so you have to replace first HA replaced by fluorine or any other molecule. So first one we replace HA by fluorine. So this one will be your H at each H. This one is fluorine. This one your methyl. NH2. Now if you want to replace Hb by fluorine, then what we get? So this one would be your fluorine. This one your hydrogen. Now you have to find out the relation between these two molecules, 1 and 2. So this 1 and 2 molecules are looking like similar, but they are not superimposable mirror image. Rather than they are mirror image to each other. Like if a mirror plane you give pair, so these are exactly mirror image to each other. So this molecule are, if one is that D, like if one will be R, then another will be S. So if looking like this, one is R, another is S, then that relation between HA and HB is enantiotropic. Now for the next cases, We have to find out relation between this HA and HB. So what we are doing? So first one we replace by fluorine. HA is replaced by fluorine. So HB as it is H. So this one is COOH. This one your methyl. Now for the next cases, so below one is replaced H. So how this molecule does this to have the same or not? So if you place the mirror, so methyl will be methyl. So this one will be your OH and this one will be fluorine. So the mirror image of this one will be look like this. So this one will be OH, this one is H, this one your hydrogen, this one is fluorine, this one is methyl. So which are not same to this molecule. So they have not any mirror image relationship. So they are not an anisotropic molecule. Now we have to find out so these two molecules are homotropic or diatropic. Homotropic means after any rotation if you give that same molecule, so that will be not possible because this methyl and this COOH are different. So they are not homotropic. If this one is methyl, if one cases this one methyl and this one methyl, so then the chance if you rotate this molecule, then chance get that homotropic. So this is an example of diastereotopic. Now for another example, so relation between these two hydrogen is also diastereotopic. Also like this example, the relation between these two also diastereotopic. So what we learned today? So we are mainly talking about the molecule have improper axis of symmetry, like that the molecule have that C2 symmetry. Then if that molecule after mirror image, like after C2, after axis of symmetry, then mirror image, and if that keep that exact the same molecule as the first one, so this molecule have improper axis of symmetry, and if a molecule have that improper axis of symmetry, then that will be an example of symmetric molecule. And if a molecule don't have any improper axis, then that molecule have an disymmet example of disymmetric or asymmetric. And for the disymmetric molecule, if there will be no axis of rotation, then that molecule will be asymmetric molecule. like your any amino acid or example of any amino acid which have the asymmetric molecule, also the chiral molecule. So chiral molecule are asymmetric. So amino acid rather than glycine one. So glycine have, so if you draw the glycine, there will be two hydrogen and this will be NH2 and COOH. So this is not a asymmetric molecule rather than any amino acid which are asymmetric, and also example of chiral molecule. Like the first one, that ethanol, which is a symmetric molecule, but if ethanol is replaced by deuterated one hydrogen, then that molecule become a asymmetric. Like any amino acid is a chiral molecule, and chiral molecule can rotate the plane polarized light like positive or negative directions. And then we have to find out that molecule have that symmetric, disymmetric or asymmetric. So we have to first draw the molecule as such a way that we can rotate this molecule like after C2 and improper axis. If this molecule give that same, then that molecule will be symmetric. So this molecule as an example of symmetric molecule. Next one also example of symmetric molecule. So this is a chiral molecule. So chiral molecule never be symmetric. So this is an example of asymmetric molecule. This molecule also symmetric. So this molecule, if we draw this molecule like such a way, and after H2 operation, so this molecule have S2. So this are also a example of symmetric molecule. Then for these cases, we have to draw that of the possible conformation. Then we have to find out that which are optically active and which is optically inactive. Optically active molecules give, there will be no sigma plane, and also they have mirror image to each other. That is the enantiomer. So between these two, so we have to replace this one Ha by fluorine, then another Hb by fluorine, then find out the relation between two molecules if they are mirror image to each other, and this mirror image are super, not non-superimposable mirror image, then that will be anisotropic relation. If they are give the same molecule after replacing, so then that will be homotropic molecule, and if there will be not superimposable but superimposable, but they are not exact that same molecule, so then that will be diastereotopic molecule, like this example. this between this HA and HB, which are diastereotopic to each other. Thank you. If you have any doubt, like another one example, you think about it. There is a above the plane and below the plane HA and HB, and this will be your methyl. So, what is the relation between this HA and HB?